All right, you guys, so we're going to go ahead and move on to another lesson here. In this case, we're focused on solving quadratic equations using substitution. We are going to be using different types of structures in this case, whether it's GCF factoring or factoring with the diamond method. So this lesson is actually a three-part lesson. This is the first part. We do have a warm-up in this case, guys. Go ahead and complete the warm-up on your own. And then let's go ahead and move on to example number 1. Now, in this case, guys, we have example number 1 here. And in example number 1, they're asking us to factor the GCF of the equation. Once again, GCF in this case, guys, stands for the greatest common factor. Greatest common factor. And we actually saw this in the previous lesson. Where in this case, whenever you're looking for a GCF, you're looking for a number that could divide into all the terms in your expression, whether they have the same number that could be divisible into all of them, or if they all have a variable, some things like that. So question for us here is, what is the GCF of this expression? What number in this case can I divide both the 4 and the 12 by? And the answer for that is actually the 4. So I'm going to go ahead and factor out a 4 here. I have a 4 on the outside, and we're going to go ahead and open parentheses here. Now, when we open parentheses, we are going to be showing this expression now simplified. So if I factor out a 4 from a 4x, I have an x left. And if I factor out a 4 from a 12, I have a 3 left. So in this case, this would actually be the expression factored with the GCF, right? So this is example number 1. Now, let's go ahead and take a look at example number 2. Example number 2 in this case, guys, same idea. We're looking for the GCF. In this case, we're looking for a number, once again, that could divide into both the 20 and the 5. Now, in this case, the GCF for that, biggest number that could divide into both of them, is actually a 5. And whenever you're looking for a GCF in this case, you always want to go ahead and check with the smallest number in the expression. If that number doesn't work, then just go ahead and move on to a number that is smaller than this one here. So GCF is 5. Let's go ahead and factor out that 5 here. So I'm going to put an equal sign. And I have a 5 on the outside, and we open parentheses. Now, if we factor out a 5 from a 20x, that's actually going to give us 4x. And if I factor out a 5 from a negative 5, I have a negative 1. So that there is the expression factored. Now, I know we have seen this in this case, guys, but it is a review because we are going to be seeing this a lot in the next lessons. So I just want to have us practice a bit more on GCFs. Example 3, let's go ahead and factor out a GCF from the expression of a negative 6x minus a 14, all right? Now, in this case, we're looking for a number in this case that could divide into both the negative 6 and the negative 14. And in this case, guys, the biggest number that could divide into both of those is actually a 2, right? Now, because my leading coefficient here is a negative, I am going to be factoring out a negative 2. Because once again, leading coefficient is negative, I have to factor out a negative. So let's go ahead and factor out that negative. I have a negative 2 on the outside. And if I factor out a negative 2 from a negative 6x, I do have a 3x left. And if I factor out a negative 2 from a negative 14, I have a positive 7 left. And once again, that is a simplified form, us factoring the expression here. All right. And in this case, after this, we actually do have a practice problem. So go ahead and complete this on your own, and I will be moving on to the next example. Go ahead and complete this on your own. Next example in this case, guys, is I want to go ahead and factor out the expression. This is example 4. And I do have the expression of x squared minus a 14x minus 21 equals a negative 6. Now, because we're going to factor out the expression, whenever we're factoring the equation here must be equal to 0. All right, our equation must be equal to 0. Now, if we ask ourselves, is this equation here equal to 0? It's not. We actually have a negative 6 on one side, and then we have this entire expression on the other. So before I actually start factoring, I need to make it equal to 0. So I'm actually going to go ahead and add 6 to both sides. Now this here, the 6 is a constant. So I'm going to go ahead and add it to my other constant here. This cancels on the right-hand side, and I have left an x squared minus a 14x minus, what is that going to be, 15 equals a 0. All right. Now that the equation is equal to a 0 here, we can go ahead and factor. Now, the method we're going to use in this case is the diamond method. So after moving the 6 in this case, let's go ahead and check for a GCF. And if we look for a GCF in this expression, we actually don't have one. Or we do, it's a 1, but it's not going to make a difference if I factor it. So let's go ahead and move on to identifying our A, B, and C values to do the diamond here. So A, B, and C. Once again, A represents our leading coefficient, which in this case is a 1. It's the number in front of the highest exponent here. It's invisible, but it's a 1. B in this case is represented by the x coefficient. It's negative 14. And C is a constant. All right. So let's go ahead and build our diamond in this case. And on the diamond, I have A times C and B on the bottom. So we have to multiply A times C, which is negative 15. And B in this case is negative 14. So we're looking for two numbers in this case that can multiply to a negative 15 and at the same time add to a negative 14. So those two numbers in this case would actually be 15 and 1, because 15 times, well, we'll see right now it's 15 and 1. But because our bottom number here is negative, it means that the bigger number has to be negative. So now in this case, if I do negative 15 times a 1, it's going to be negative 15. And if I do negative 15 plus a 1, it's going to give us that negative 14 on the bottom. So from here, we do have to rewrite the expression here as a binomial. So let's go ahead and rewrite it as a binomial. And because our leading coefficient is a 1, we're actually done here. I don't have to do grouping. I'll just go straight off to writing the binomial on this side. So that's going to become x minus a 15 times x plus a 1 equals a 0. Now in this case, guys, we're just factoring out the expression. I'm not going to solve for x here. But in this case, we are done. We did factor out the original expression. All right, let's take a look at the next one. Same idea. Factor the expression. And we still have to use that same idea of if we need to factor out an expression, we do have to make it equal to 0. So whenever we're making it equal to 0, we could move all of this to the other side, or we could move that negative 3. But in this case, I want to go ahead and keep our leading coefficient here, which is x squared. I want to go ahead and keep that positive. So because I want to keep it positive, I am going to be moving that 3 to the other side. So I'm going to go ahead and add a 3 and add a 3. 3x cancels. And that becomes, in this case, an x squared plus a 3x minus 10. I did put this in order. I did put it in standard form. So let's go ahead and move on to factoring because this does not have a GCF. So I have A, B, and C. Leading coefficient is a 1, x coefficient is 3, and constant is negative 10. Moving on to a diamond in this case, A times C on top, B on the bottom. Product of A times C, guys, is negative 10, and B is a 3. So two numbers that multiply to the top and at the same time add to the bottom would actually be 5 and 2. And since my bottom number here is positive, that means that the bigger number is positive. So this one should be a negative. Now, because our A, or leading coefficient, is a 1, let's go ahead and write our binomials. In this case, that should be x plus 5 and x minus 2 equals 0. And that in this case, guys, is the expression in factored form. All right. let's see what's next. In this case, next thing is for you to rewrite the expression here in standard form and factor it. So rewrite the expression and factor it. All right, so go ahead and do that. You do have 2 practice problems for this lesson. So that's it. Thank you.